Welcome to this hands-on lab. My name is Mats Stellvall. I work as a principal architect for AI and ML at Snowflake, and I'm going to be your host for the next 60 minutes when we walk through this hands-on lab. Before I go into the presentations, there's a couple of things you need to do in order to be following this. One part is, of course, to get the hands-on lab guide. You can access that through the tiny URL, or you can use the QR code. The second part is you need to get to the Git repository. In the Git repository, there will be a notebook that we're going to use for this hands-on lab. And once again, you can use the tiny URL or you can use the QR code. So let me just show you. And if these doesn't work for you, the simple ways to get to the hands-on lab is to go to quickstarts.snowflake.com and then search for pandas. And you will find here data engineering pipeline with pandas on Snowflake. This is the guide that we're going to use. If you click on start, you will get the instructions. And if you scroll down, you will find a link to the actual Git repository. So if you click on that, you will get to the Git repository, which you then can either clone using Git commands, or if you do have challenges with using Git directly on your laptop or computer, you can just click on download zip. And once you do that, it will download the Git repository as a zip file to your local drive. You can then extract it and access the files directly. The last thing you need to make sure is, of course, that you have access to a Snowflake account. You do need to have the account admin role for that account. So if you need a new one, you can use the trial.snowflake.com, which allows you to create a new trial account. And the thing you need to have in mind is that you need to, of course, fill in your first name and last name and email and so on. Then you need to choose a version of Snowflake. My recommendation is to use the enterprise version. You do need to select the cloud. My recommendation, once again, would be to use AWS and then choose a region that is close by to you. Once you have filled in and answered all the questions, you will get an email in a couple of minutes where you can then activate your Snowflake account. This account will be available for you for the next 30 days, and it's free of charge. So while you do these things, let me get into the presentation part of this. So during this lab, we're going to touch on a couple of things here. We're going to have around how we can authoring pipelines. We're going to look into how we can do transformations, how we can do orchestration of these pipelines, and how we can do some simple DevOps. When it comes to the authoring and experience part of it, we're going to use Snowflake Notebooks. And Snowflake Notebooks is available for you directly in the Snowflake user interface, what we call SnowSite. And it enables you to write both Python code and SQL code in the same interface. You have the possibility to use either Snowflake Standard Compute, or you can actually also use Snowflake Container Services for executing your code. During this lab, we're going to use the standard warehouse version of it. Now, the notebooks can also be using Git repos for versioning, handling, and so on and so forth. And we can also schedule these notebooks, which we're going to look a little bit into during the lab. For transformation, we're going to use the Snowpark Pandas API. Now, the Snowpark Pandas API is part of the Snowpark API. So you might be familiar with that since previously, where we do have a dataframe API that is following Spark when it comes to the function and method names. The Pandas API of Snowpark is following Pandas, of course. So that gives you the possibility to reuse your skills and knowledge in Pandas, but having that executed on Snowflake. Now, how does that work? Or why should we use it at all? Now, one challenge with standard Pandas is it's single node bound. It is dependent on the memory I have available on the client I'm running it. That means if I'm using large volumes of data, I will risk running out of memories. Now, by using Snowpark Pandas API, I don't have that boundaries. I'm using Snowflake Compute and the Snowflake SQL engine, which means I get a distributed execution of my code without the need of worrying about what type of size I need to use. The other part of this is, of course, if you have your data in Snowflake and if you have sensitive data, you want to reuse the implementations of the security and governance features of Snowflake and doesn't need to have to worry about what happens if I pull out the data from Snowflake. So with Snowpark Pandas API, you don't have to do that, worry about that anymore. And of course, another benefit is many times when we're using standard pandas to develop things, we might work with sample data or smaller data set. And later, when we put that in production, we might realize that, oh, the data we're using for running in production is so much larger than the data we use for development, which might result in that we need to rewrite the code we have in order to work with larger volumes. So how does the Snowpark Pandas API works? Basically, and simply looking at it from a simple way, it takes the code you write in Python. So you're using familiar pandas methods and functions. So in this case, I'm using concat. Once I execute that, that is translated into SQL and executed in Snowflake using our SQL engine, meaning you get the distribution of the execution, the parallelism that we provide, and so on and so forth. Me as a developer, I don't need to know anything about SQL, but still I can utilize that. If I'm using custom functions as part of, for example, using the pandas apply function, this is not translated to SQL, but the code is pushed down to be executed on the Python secured sandbox that we are running in your Snowflake environment. So the data will still stay in Snowflake, and you get all the benefits of the security, the governance, and the way how we execute. For orchestration, we're going to use something called tasks. Now, you can think of tasks in Snowflake as objects you use to execute code. These tasks can be scheduled, or they can be triggered based on another task. So you can create a DAG of tasks where you have one task that's executing that spans out into additional tasks and then spans in again for a last task running. The way we run tasks is either by what we call user-managed warehouses, meaning you define what compute you're going to use, the size of that compute, or we can run them as serverless, meaning they are Snowflake managed warehouses, where Snowflake will figure out, based on previous runs, what is the optimal size of the compute to be used in order to execute these tasks. The benefit of this, of course, is me as a user, I don't need to figure out what is the most optimal size of the warehouse or compute I'm using. I can let Snowflake manage that. So that gives me a more dynamically use of compute resources, which will lead to a better TCO. Now, the serverless task supports to be built on SQL command, but we also now support using Python code as part of these tasks. And this is what we're going to do today in this hands-on lab. Finally, we're going to do some simple DevOps as part of creating tasks. And for that, we're going to use the Snowflake Python API. The Snowflake Python API is an additional Python library that you can install and run locally, or you can use them in the Snowflake Notebooks. The Snowflake Python API enables you to work with different types of Snowflake objects using Python code. So you can manage your Snowflake environment without using SQL, just using Python. And we're going to use this today in order to create some tasks. So with that introduction to the various parts we're going to have, we're going to go in a little bit more in the hands-on lab we're going to do together. So the flow of the hands-on lab is we're going to use existing Snowflake data. We're going to create a notebook or run a notebook where we're going to use Snowpark Pandas for aggregation and visualization of data. We're going to create new features, and we're going to save the result of that in a table in Snowflake. Then we're going to create the serverless task to schedule the running of this pipeline. We're also going to look into a little bit how we also can schedule the notebook if we prefer to run the notebook. So let's move over to our Snowflake accounts and start the actual hands-on lab. There's a couple of things I need to verify before we run this. One is that I'm running as account admin. So if we look down in the left corner, we can see the name of the user we're using and the current role. If it doesn't say account admin, we can just click on the up arrow and we can switch role and choose account admin. We also need to verify that we have access to the Snowflake sample database. And we can see that if we go into the data part, we see databases, and we can see, hopefully, that we have the Snowflake sample data. If you don't have it, you need to add it, and this is very well documented in the Snowflake documentation, how you can do it. So we also need to prepare the environment for running. So if we go to the guide, we can see we have the overview first, and then as the next step, we also have how we set up the environment. So hopefully we all have cloned the Git repository, or we have downloaded the Git repository, so we have access to the notebook. Now, if you want to be extra fancy, you have, of course, set up a Git integration in your Snowflake account, and then you don't need to download anything. You just need to clone or fork the GitHub repository. Once we have that, we need to create some objects. So we're going to create a new database and a new schema, and then we're going to create a warehouse. So a compute resource we're going to use to execute the code. The simple ways to do this is, of course, to copy the code and then go back to my Snowflake account. And what I can do is I can click on Query Data. That would open up what we call a SQL worksheet. And if I paste the code I have here, and then I click on the down arrow and run all, it will create the database, it will create the schema I'm using, and it will create the warehouse for me. Now, I'm not going to run that because, as you can see, I already created this a while ago, but you all need to run that before you can actually do anything. If we go back to the quick start, we can also see that we need to import the notebook that is part of the Git repository that we have now available locally. So if I go back, I hover over what we call projects, then I can choose notebooks. And you might have something there or you might not have anything. So now you have the options to say either create from repository. That is a path you can take if you have set up Git integration with Snowflake and your Git repository where you have forked the repository. Or if you have the notebook locally, you can just choose import EPI file. And we will get the dialog, and I apologize for this is small. You need to navigate to the folder where you have extracted the Git repository. And within that folder, there's a notebooks folder. And there you have the first one, the one that is called Zero Start here. Once you're there, you click on it, you click on Open. We have to give it a name. We can keep the default name. We need to point to a notebook location, meaning where will we store our notebook? So in this case, I will choose my new database. I will use the notebook schema, and then I will choose my Snowpark Pandas DEQS warehouse. As you can see here, I can choose between using run on warehouse, meaning I will run this code on this warehouse, or I can also configure it to run on a container. That means that I beforehand need to create a compute pool that I can use for this. Now, for this hands-on lab, we don't need to run on a container, but if you had, for example, a need to run something that needs to use GPUs, you can use a container version of it. Once we're happy with this, we click on Create, and we will now import this notebook. So this is a great way if you already have notebooks you created with other tools like VS Code or Jupyter, and you want to use them in Snowflake. So we are ready to start, and you can see here is if I have a Git repository, I could also connect to it and upload and save my notebook there as well. There's a couple of things we need to do before we start running this. I need to add some Python libraries to it. And in this case, we're going to use the Modin library, the Snowflake library, the matplotlib library, and the Seaborn library. The way to do that is to go up to the package menu and click on the down arrow. And then we use search for the package we want to use. So I want to use Modin. It will give me suggestions, and the one we are after is the one that is called Modin. Now I have a choice here. I can say, give me the latest one that is available, or I want to use a specific version. So I want to pin this to a certain version because I know I want to use features that is available there, or I want to make sure that every time I run this notebook, I will always use the same version. So for this example, maybe we want to pin it to 0.28.1. So I choose this. That means every time I open and run this notebook, it will use this specific version. I also want to add the Snowflake package. So I search for snow. I have a Snowflake. And in this case, I say, well, let's use the latest one. I don't really care if which version I'm using. We're also going to add the matplotlib. And finally, we're going to add Seaborn. And what you can see as we go along in this also, that once I started to add additional packages, there's a new file that is created here, which is the environment YAML file. And if I click on that, I can actually see now that if I export this notebook, I can also export the environment YAML and easily set up the same environment outside Snowflake to be able to run parts of this notebook. It also means when I check in this into Git and someone else checks out that notebook into Snowflake, it will grab the same libraries for me when they open up the notebook. Once we have done this, I click on Start, which means now we're starting the compute. Part of this is, of course, setting up the Python environment and adding the packages I need in this. So this will take a couple of seconds for us to run. And I'm good to go. What I'm going to do now is I'm going to remove my sidebar here. So down here, you have a button you can click. So I have more space here. I'm going to start off by importing some libraries. So first my Streamlit, because I'm actually going to use some Streamlit functionality here, matplotlib, Seaborn, and then I'm going to import the libraries needed in order to use the Snowpark Pandas API. So I need the Modis Pandas, and I need the Snowflake Snowpark Modin plugin. And finally, since I'm using this Python library, I also need to have a session for it to use with Snowflake. So it does know who I am, what role I'm running, what is the context I'm running this in. So what I can use is I can import something called getActiveSession and just call that function. So now I'm running this as me with the role I had when I logged into Snowflake. So I'm ready to start now. And the first thing, what are we going to do is we're just going to set some context variables in this. So what I'm keeping track of is where's my source data? So in this case, I'm picking up the Snowflake sample data. I'm using the schema called TPC-HSF1. There's a number of these schemas. So if you want to test this with larger volume of data, you can change it to SF10 or SF100. So then you will be using up to 1 terabyte worth of data if you're interested to see how it behaves. Then I'm just going to set the context in the sense of when I'm saving a table or creating a temporary table, where will that be saved? In this case, I'm going to put it into our new database and new schema. So what I'm doing here is saying use this as the default schema. Now I want to create my Snowpark Pandas data frame. I'm going to use one of the existing tables I have. So I'm going to start with the line item tables. I'm only interested in the number of these columns. So I will create a variable that contains the columns I'm interested in. And then I'm just going to say read Snowflake, meaning I'm going to use an existing table in Snowflake as the source for this. And this is the columns I want to use. Basically the same thing you would do if you're using Pandas and just want to explicit get a couple of these columns from the data frame. If I want to look at the Snowpark Pandas data frame, I'm using head the same way as I'm doing with Pandas, so the same functionality. And we can see the 5 first rows of our Snowpark Pandas data frame. Each of these has an order key, a line number, a part key, a return flag, quantity, discount, and extended price. So this schema or this sample data is fake data for a retailer that does business in online and in stores and so on. So we're going to work with order data that has line items. So each and every order have one or more lines. If I want to get some info about my data frame, I will use the .info, and it will return basically the same thing as I would use a normal Pandas data frame. Of course, the class is Snowflake Snowpark mode in Pandas data frame. We have a Snowflake index, but you can see we get the same type of D types. So int64, object float 64, we get the same information of how many of each and every of these D types do I have in my data frame. And we can see that the memory usage on the client side is 0 because the data is in Snowflake and not in memory on my client. So that means it doesn't matter how much data I have, I don't need to load that data into memory in order to use that. And if I want to see the shape of this, so the number of rows, the number of columns, we can see that we are running about 6 million rows with 7 columns. So it's a fairly standard size data frame, I would say. So we have the basics here, and we want to continue. So let's do some filtering to start off. So we have in this data, there's a return flag that indicates whatever item is delivered or returned, or if the order was aborted. So we annihilated the order and didn't send it. So I'm not interested in those. I'm only interested in the line items that has been delivered or has been returned. So I'm just going to add a filter to this to say, give me the data that doesn't have the flag equal A. And once again, it's the same familiar way of doing things as I would do with Pandas. So that means I can reuse my knowledge. I can use this basically the same code. The only difference is this is executed in Snowflake. So we see we had 6 million rows. Now we have 4.5 million rows after the filtering. And the way we do filtering is exactly the same way we do it in Pandas. So let's do some calculations. Let's create a new column. So I'm going to add a discount amount. So just want to calculate how much actual discount they get in a value for each and every row. I'm going to use that later as a feature. And then I want to aggregate this because I'm not interested to keep this data on a line item level. I'm more interested to have this on an order level. So I'm going to keep track of how much amounts I have, how many, the quantity and the discount amount, and I want to know this by order and whether this is a return or not. So we do a group by. The way we do a group by is the same way we do it in Pandas. I can do multiple aggregations by providing a dictionary with the column, the type of aggregations that is going to be done. I can use the ag function. I rename the columns because I want to have names that I control. And then we can do ahead and we can see now we have for each order, we keep track if it's a return or not, the number of items, the total discounts amounts. The next thing I want to do now is we want to split it up. So we want to create multiple columns. So I want to separate the number of items, the total discount amount by the return flag. So I want to see how much money they spend on returns versus on delivered goods here. So I'm going to use the pivot table function, which basically do that for me. So I'm going to say what is the value columns, what is the index, and which columns I'm going to use to generate new columns. So using the same functionality as we're used to. And the second thing I'm going to do is I'm going to rename the columns that is returned, because the pivot table will create sub columns. So for each and every primary column, it will create a sub column, and that just looks strange. So what I'm doing here is I'm just renaming the columns, I'm resetting my index, and now I don't have sub columns, I just have standard columns, so to speak. And I can see for each and every order, what is the number of items, if it's a return, what is the discount amount, and so on and so forth. So now I have created some order features, but I also, based on my line items, and then I want to create some features based on the order, and I want to combine this. So I'm going to read a new table and create a new Snowpark Pandas data frame based on an additional table in Snowflake called orders. There's a number of columns I'm interested in, but instead of specifying the columns I want to keep, I'm using the drop function or method to drop the columns I don't want to keep. So in the first case, we were specifying which of the columns we want to keep. And now as a second one, we just drop the columns we don't want to keep instead. So here's my additional data frame. I have the order key, which customer is, what is the order status, what was the total price, what was the date. I want to join this, and if you're familiar with Pandas, the way to join to data frame is to use the merge. It works the same way with the Snowpark Pandas. Using the merge, what is the left, what is the right key, and how I want to do this. Then I'm just going to drop the L order key, because that has the same data as the O order key. It's just that they have different names in the different tables. So executing that, we'll see that we now have about, if I'm not calculating this wrong, we have about 1.3 million or almost 1.4 million rows. We have 9 columns, and we can see some sample data of this here, or we can see the head of it. So I have combined the two data frames now. I have done some aggregations, and what I want to do now is do some additional aggregations. So I want to aggregate this by customer, because in the end, I want to save this as customer features in the table. So I'm not interested in actual orders. I'm not interested in the line items, but I do want to be interested in per customer to know how many orders have they done, what was the total price, so how much did they spend with us, what was the mean, the median, the same thing for the number of items they have ordered and haven't delivered, but also the number of items they have returned. I'm going to look at the total discount amount for each of these. So once again, we can specify how we want to do the aggregations. So the columns, the different type of functions I want to call for it. I do the group by the same way as I do in Pandas. What is the key? Is it an index, the aggregation, and then I'm just going to rename all the columns, so having them in the right way I want to call them. And I now have a new data frame. So with this data frame, I have all my calculations. I have a pretty nice overview of customers. I have some nice features. I just want to add 2 additional ones that I will calculate now as a side thing, which is the average discount and the total discount that they have gotten. So let's just add those. As you can see, we do the calculations the same way we could do with the standard Pandas data frame. But the difference here is this is executed in Snowflake. This is generating SQL, so we're utilizing the way how Snowflake works and how Snowflake can execute SQL. So we see there's a number of columns here, and I'm pretty satisfied with this. And I can use this now for various reasons. So what I'm going to do now is I'm going to save this. So far, the transformations I have done, they only exist as logical transformations. So they exist as the SQL that is generated by my data frame, but they are not materialized in Snowflake. So I want to save this because I want to use it for something else later on. So the way to do that is to say, well, to Snowflake, give it a name. So this is the table name. What am I going to do if this table already exists? In this case, I'm just going to replace it. But I might want to append to say I'm going to build this up and add new data as we go along. And then I'm just saying if I want to add the index or keep the index column as a separate column. So what happens now is the transformations that we have done to the data frame is transferred to SQL, executed in Snowflake, and stored in this table. So I can then use a SQL cell in my notebook. So I can write a specific SQL and run that, and I can see that we now have data in this table. So what I've done now is I've been using the Snowpark Pandas API to do some basic aggregations, joining some tables, doing some transformation, meaning I have been creating some additional features, and then I have saved that into a physical table in Snowflake, meaning now anyone can use that data I have. So before I continue, so let's just visualize that. So the Snowflake Notebooks give me the possibility to do visualization as well. So in this case, I'm actually using Seaborn to do some distribution plots, just to look a little bit how the distribution of number of order is, how does the average order amount look like, the average items delivered, just to get some feeling about the data I have. And I can see how, if it is skewed in any way or if it's normal distributed and so on and so forth. So we have our features, we have saved them, but in this case, I want to run this on a regular basis. We get new data every day, and I want to orchestrate this. So I want to run this as a data pipeline. As I said previously, what I can do is I can schedule this notebook, and it's very easy to schedule it. So you can see up to the right top, next to run all, there's a schedule. And I can say, well, create the schedule for this. And then I can give it a name, whatever name I want to. I can say how often it's going to run, what is the time zone for it. Are we going to use parameters? So we can have parameters with notebooks that I would provide. Maybe I want to give the table name, provide a table name when I run this. And once I say create, this will run automatically now. However, I'm not interested in this. I want to run this as more as a Python pipeline, meaning that I want to use serverless tasks and I want to just run the code. So what I'm going to do is I'm going to create what we call the Python store procedure. And you can think of a Python store procedure as a Python runtime environment in Snowflake where you provide Python code either by inline, meaning I provide the code directly, or I can have the code in a file that is in a Git repository that is connected to Snowflake, and it will pull that code every time it runs. In this case, we're just going to provide the code directly to the store procedure. So I'm also going to use the Snowflake API. So remember, I was mentioning the Snowflake Python API as a Python interface for doing DevOps with Snowflake. So we're going to use that for creating a task. So I'm importing some modules from the Snowflake core library. In order to create my Python store procedure, I need to define a function for it. So I create the standard Python function. The only thing I need to do is the first parameter to that function needs to be of a Snowpark session object. Because when this is running, it is going to be provided with a session by Snowflake based on who is running this store procedure. Then I'm just having some additional parameters. So where is my source data, where I'm going to save the data, and then it's going to return a string. And what I've done here is I pasted in all the code we have been using. So we're using the Snowpark Pandas API as well here. So it's the same code that we did previously. It's just wrapped up in one function. So I have defined the function. before I create this stored procedure, I also need to create a stage. And the stage in Snowflake is basically pointing to cloud storage. The cloud storage can be outside Snowflake or it can be within Snowflake. Now, by default, when I say create stage if not exist, this will be handled within Snowflake. So in your Snowflake account, this is where this stage is existing. Then I'm going to register my function as a stored procedure. And the way to do that is to use the Snowpark sproc register function. I give it a name. So this is the name it's going to have in Snowflake, which is create customer profile SP. I point to the Python function I'm going to use. So in this case, this is the function that we defined up here. So it's going to take that function code and generate bytecode for it and upload it to Snowflake. What is going to happen if this stored procedure already exists? Is this a permanent stored procedure, meaning when I close this session, the stored procedure will still exist? I could create also a temporary stored procedure, meaning it will only live as long as my session is living. But since I'm going to run this as a task, I need to create a permanent. That means also I need to provide a stage location to say where will this code be stored. Then I also need to provide what is the Python libraries that I'm dependent on, apart from the standard ones, and I'm using Modin and Snowflake, Snowpark Python. If I was a good citizen, I would also provide the specific version we're going to use, but in this case, I'm not doing it. And since this has run, we now have a stored procedure. I can call that stored procedure using SQL, for example, or I can use Python. And the way to call it using SQL is the stored procedure name and then the two parameters. So now I have my stored procedure. I want to schedule it using task. I'm going to create this task using Python. So what I have is I create a task object. I give it a name. The definition is basically the SQL call to say, call my stored procedure. This is the input that I will provide. My schedule is time delta minutes 1, meaning this will run every minute. Now, if this is this something I want to have in production? Maybe not, but for this demo or this hands-on lab, 1 minute is quite good because then it can run while we are doing things. So I will also create it. So this has defined my task, and by calling task.create, I actually create it. So I can use SQL to check for this task. I can see, do I have a task? Yes, I have a customer profile task. It is in my new database, in my schema. However, by default, when I create the task using Python, the task is disabled. That means, or suspended, it means that it doesn't run. So what I need to do now in order to run this, get this task running, is to call the resume. That means when I call resume now, it will wait 1 minute and then it will run. So one thing we can do while we wait for it to run is to look at it. So we looked at it from a SQL point of view, but what I can also do is if I'm hovering over databases, and let's just right click and say open link in a new tab. So I don't have to go back to my notebook. I can navigate to my now Snow Pandas DQS, my data schema. And within there, I have something called task. We can click on it and we can see this is the task we created. We can see it's going to run every minute. It has some default parameters which say if this fails for 10 times in a row, we will suspend it. So that means if I did a mistake with my code, it will not try to run endlessly. So it will actually suspend after a while. I can see what is the definition of my task, who is owning it. I can look at the graph. In this case, my task has only one step, so I haven't created the DAG. If I had more steps, I would see them. I can click on that. I can get some information. I can see it's serverless. It was created a minute. It will run every minute. It's a root task. And then I can look here at the run history. So we can see it has run or executed. It was succeeded, when it's going to run the next time. And we can see how long it took. So it took 25 seconds, 1 minute, and then it took 27 seconds. And the nice thing with serverless is the more runs we do, the more statistics we gather around it, and we will adjust the needed compute accordingly. So if my data would grow, so I will get more and more data in, we will adjust the serverless compute in order to get the good performance for it. So let's get back to the notebook. And what we can do here now is we saw, obviously, in the GUI that it already run, but I can also look at it from a SQL point of view. So I can run a SQL that look at what we call the task history, and we can see that we have been running this task 2 times. And then, of course, I can use the SQL to just see what tables. So every time this task is running, we're creating a new table. So we are not depending, we're just creating a new table. So this was an example of how you can use the notebooks and how you can build a data pipeline using the Snowpark Pandas API, and how you can then schedule this either using the schedule functionality of notebooks or using tasks and serverless tasks. One thing before you leave this notebook is what I recommend to you do is what we call the cleaning up here, meaning at least you need to run the task res suspend, because that will save you some credits. Because the way how this task is working and the way how the code is working, it will pull data from the same table every time. So you don't want to have this ended up running once a minute once we're done with this lab, because that will consume some credits for you. You can then also drop the tables that the task has created, so we can run this simple code using the Snowpark Python API, so the DevOps API, in order to delete tables or drop tables. And we can now see if I run this, that I hopefully doesn't have any tables left. So let me get back and to summarize a little bit what we have been doing. We have been using the Snowflake Notebooks in order to write our code and run our code and test our code. We have been using the Snowpark Pandas API to do all these transformations. So we have been reusing the previous knowledge we have in how to use Pandas, but with the benefit that now all the code is executed using Snowflake SQL engine, giving us the possibility to work with bigger volumes of data for one thing. We have then used the serverless task in order to orchestrate this pipeline we created, and we used Python to create this. And by using the Python API, we didn't have to write any SQL in order to do that. And of course, we could have saved the notebook into Git using the Git integration. And if you're interested in how to use that, you can obviously look at the Snowflake documentation that describes how you can set up this. And if you want to know more and get some hands-on of some of the concepts that we have touched on, there's our quick starts available for you around CI/CD Python pipelines, how you can use Snowflake Trail, and how you can do some more DevOps. Please use the QR code that you can see on the screen for getting access to those. And with that, I will thank you for participating in this hands-on lab, and I hope it has been valuable for you, and best of luck with your usage of Snowflake and Snowpark Pandas API. Thank you.